In this video, we're going to learn about something called an order of magnitude model, which is useful for getting quick, approximate estimates of quantities. This technique is often called a Fermi question or a Fermi problem, and is named after the physicist Enrico Fermi because he was well known for his ability to make good approximate answers to questions using very little data. So what is an order of magnitude model? And more importantly, why do we care? These types of questions generally involve making justified guesses about quantities and the ranges of those quantities. And they're commonly used because they give quick estimates to questions and also to the ranges of possible answers. They're also useful because you can use them to check more complicated models. If that more complex model in a similar situation produces wildly different results, it's worth looking into it a bit more. Because as long as the initial assumptions in the estimate you create are reasonable, the result that you get will give an answer that's within the same scale as the correct result. If it's not, it gives you a place to understand, to start understanding why this is the case. So how does it work? The core of solving Fermi problems is dimensional analysis, which is a fancy term for unit conversion. The basic idea is as follows. Let's consider a problem. How fast is 10 miles an hour in feet per second? So let's start. So we have 10 miles per hour times 1 hour has 3,600 seconds. And then the hour units cancel out. So now we have 10 miles per 3,600 seconds. And we want to find out how many feet that is. So then we multiply that by 5,280 feet per 1 mile. And then the miles in the numerator and the denominator cancel. And what we end up with is a number that's something like 14.66 repeating feet per second. And so this is what gets us the answer, because what we're doing is we're starting with the thing that we know, 10 miles an hour, and then we're just applying conversions to it and keeping track of our units until we get the answer that we're looking for. So here's the process that we're going to use when we do order of magnitude approximations. First, we're going to pose the question that we want to know the answer to. Then we need more information to answer the question typically, so we're going to start making conversions using the new unit analysis we were just talking about and guess at the value of those conversions if we don't know them. And then we're going to guess at the range of values you might have for each part of the model. And by doing those three things, posing the question, making the conversions, and then guessing at the range of values, we'll get not just an answer, but given the range of values, we'll get a variety of answers, or a range of possible answers that should bracket the more accurate answer that we would get from a more sophisticated or more complicated model. So now let's do an example. So the problem that we're going to answer are how many babies are born each day. We're going to need to know several things to calculate this. First off, the number of babies that are born depends on the number of people there are in the world, so we need to know that. Furthermore, we need to know what fraction of those people are female, because women are the ones that have babies. We also need to know how many babies the average woman has per lifetime. There's, of course, tremendous variability, but there has to be some average number. And then we want to know how long does the average woman live, because the number of babies per lifetime divided by how long an average woman lives is the probability that a woman would have a baby on any random day. So now we're going to take some guesses at these numbers. So in terms of how many people there are in the world, we're going to say it's something like 5 to 10 billion. And the actual number is 7.4 billion. What fraction of them are women? Well, we'll guess that it's half, and the actual answer is 0.496. How many babies there are born per lifetime? Well, when I started this, I wasn't sure. So I guessed somewhere between 2 and 4. And it turns out that the actual answer for all women across the world is 2.33. And then how long does the average woman live? And we're going to guess somewhere between 60 and 80 years. And it turns out that the global average is 73.5 years. And so now what we're going to do is create an equation that puts all of these quantities together. And then what we're going to do is we're going to plug in the median number, or the number that we think is pretty close to being correct, so the things on the right side. And then we're also going to put in our ranges, so 5 to 10 billion for the number of people, 2 to 4 per babies, 60 to 80 per years, to see what kind of range of values we get. And then we're going to compare it with a more sophisticated example. So we calculate that the number of babies born today is just going to be the number of women in the world times the probability of any given woman having a baby on any given day. And this, of course, is a simplification, but that's okay. That's the point. Then the number of women is going to be the size of the population of the world times the fraction of that population that are women. And then the probability of having a baby on any given day is just the number of babies that a woman is likely to have in their lifetime divided by their lifetime expressed in days. So then when we put all of the ranges in, we get that the number of babies born today is 5 to 10 billion people, half of which are women, 0.496 of which are women, times 2 to 4 babies per woman, divided by the lifetime, which is somewhere in the range of 60 to 80 years. Or, if I put in the numbers that I looked up on Google, then what I find is it's the number of babies born today is about 7.4 billion times 0.496 times 2.33 babies divided by 73.5 years. Because 7.4 billion is the human population, 2.33 is the average number of babies that a woman has, and 73.5 is the average life expectancy of a woman. And these are all numbers averaged across the entire world, so it includes populations in all countries. When I plug in these numbers, what do I get? Well, when I plug in the numbers that I know are correct, I get an estimate of 330,000 babies born today. And then when I take the ranges that I came up with and try the high and low numbers to get the largest and smallest number that I can for the number of babies born today, I get a range of 170 to 900,000. So how many babies were born today? Well, so what we're going to do is we're going to ask Google. So we say how many babies are born each day, and the first thing that pops up is the UNICEF estimate. And this is an international organization that does a lot of this sort of thing. And so their estimate is that 353,000 babies are born each day around the world. And this is using demographic data from around the world and also very sophisticated statistical modeling, which takes into account the fact that the population is changing over time, that not everybody is equally fertile, that it's and a variety of other important factors. And so 353,000 is within 10% of our simple estimate for the number of babies that are born each day. And it's well within the bounds of our upper and lower limits of 170 to 900,000 people, 900,000 babies born each day. And so this is one example of the kind of order of magnitude approximation or Fermi question that we can answer, and we're going to do a lot more of those in class. Thank you very much. Have a good day.